Well, obviously, hey everyone. Seen a lot of videos with me and Farshad, of course, but hopefully you guys like them. A couple things to go over: drilling, of course. Going to chat about the copper market, and then go into a little bit. Professor Farshad is going to show us share screens of what he's doing in terms of the drilling. Show some 3D modeling. Farshad, how are you?
Hi, Jason. Thank you for having me here today too. Thank you for all your viewers and supporting us in the market. Get the support going. I think we're doing really good.
I want to talk copper rumors. What do you think's happening with copper? Obviously, we're seeing some things come out. Do you want to address them?
Yes, actually, the news that I have is very fresh, new, still hasn't hit the market, but it's very, very shocking. The day before yesterday, I was talking to the person who's responsible for all the food and logistics at Grasberg. I talked to him. He said he's off by the end of September, but as of today, Grasberg is a big hole. All it means there's nothing in it. It's going to be shut down, and that has provided a lot of copper in the world. And this is the first time you hear from that. And he's out. He said, I'm out by the end of the month, and it's no longer is going to be operational. Do
Wow.
you know what it does to the copper market? The copper market and also the gold is going to have a huge jump. I believe it's going to be in 2 3 months. We're going to see copper to 350, could be even at $4 a pound.
So things are looking even spicier for Doubleview, is what you're saying, potentially.
Yes, W, as you know, is not one pony trick. It's got copper and gold, both of them together, plus, of course, cobalt, palladium, and others to be yet added to our numbers when we report it, which we are working on it. But, the good days are coming. And I heard last night, it's on CNBC, that China is rushing, just starting to pound copper and buy it. That made a big jump yesterday in the copper market. I expect in next week, gradually this go up. On average, a penny in copper is about $20 to $25 in gold in value.
Wow.
That's how they compare it with each other.
Do we want to start? Did you want to give a little drilling update, and then we can maybe nail off the list and then hop into some 3D modeling stuff?
Instead of discussing that and saying that verbally, people may love to have a look at this, like on the 3D model. I'm going to share the screen in here, explain it right here. I'm going to rotate it first just to show you what this model is about. This is the topography of the HAT project. The reason I'd like to show this to the viewers because it's really flat. You can see, really, really straightforward. The property, we walk from one side to the other, basically maybe meters, 5 meters to 10 meters difference in elevation. I'm going to put the 3D model in here. This is the IP. This is run down version of this IP model, which is going down. Basically, what we have received as deep, it's shown as deep as 1250 meters, but as deeper we go, of course, the certainty of the values are getting less. It's hard to really bank on it.
Do you want to just explain to people, why this, I guess the accuracy or at least the certainty level decreases? How sure they are that deeper you go, that things are there.
So when IP, which is induced chargeability, happens, the nodes are put in two separate places in a very layman language, and there are two measurements happening outside or inside those electric charge, and then decay is happening after the charge is removed from the nodes. They are measured. If there's no sulfides in there, there's no IP is happening, induced polarization all of a sudden goes to zero because it doesn't get charged. Sulfides get charged and they decay gradually. the more this gradual processes, the number is bigger. And you can imagine when you have two nodes, the farther they go, the deeper the current is, and it gives more understanding of the at depth. But as you get deeper, the accuracy is lower because the current has to go through a lot of mass to get to each other and measure it. This 3D IP has been really powerful IP. First, in the array that they put together, it's been 9 rows they put together, and plus they have measured constant data, and it's a very new and unique technology. Why do we spending a lot of time and emphasizing on this? And this is our exploration model, because in the past 2 seasons we drilled the project and we know it works. Now we know a little more that outside even this area that we have bounded to be our model, still we have mineralization. But at least inside this model, which is 12 millivolts, we have mineralization. So that's why we don't want to go away from it. This is 1200 meters. We are emphasizing on this much of it, roughly. And the reason why is after that, we want to, it's deeper, harder to really read the measurements, and I want to emphasize on the top one. And as we go ahead, this is good about 950 meters easily. Out of that model, we use this model, which is, I colored it a little bit, and I made the number from 12 to 14 millivolts. The reason I'm doing that, still I want to make our volume tighter to make sure when we drill it in the right spot. If I am right, let me bring up some of these are the proposed drill holes. They are based on different criteria. These are the proposed drill holes in comparison to some of the original drill holes. Basically, I'm going to turn off the 3D model. You see, this is drill hole 23. Everyone knows what's happening with drill hole 23. Let me bring up values on that. This is drill hole 23. This is drill hole 22. This is drill hole 34. You see, complete hole has been mineralized, and this is the current hole. I've shown it now to 1,000 meters yet. We're gonna go deeper, of course. If you look at the model, this is the part, you see the mineralization is happening even a little bit outside this model, and that's what we are working on. I want to show you from bottom. This is the drill hole 35. You asked me why you have some degree of technical confidence on this. Technically, we are inside the model. I rotate that drill hole 35 so you see how deep it goes. This is to the depth of 850, 900 meters, and it's still, if it continue on that, you see it's gonna fall right into it. And that's why we are banking on this, and we go deep on this. I love it because I put this drill hole coming right at the end of this. Somewhere in here, technically, we should have a feeder zone. That feeder zones are, once you fall into it, they go to, I don't know, at Grasberg was 8.5 kilometers, never died down, and even getting richer. So that's what we do.
So I'm saying, you have it here up to 1,200 meters. Just for people, how willing are you to draw, to drill this hole?
I'm prepared to 2,000 meters. It took me a while to put this technical and test it to see if it works. We have done a method that we go with the same machine that doing on paper can do to 1,500 meters. We are going to go to 2,000 meters, and it has been done in the past. I found the people that they did it, and I'm willing to go to 2,000 meters as long as it takes. And of course, we are at the mercy of 2 items. The drill itself that can run it at that depth, it gets really heavy. The rods are going to be pounding up on top of each other. The machine has to be able to drill it. It can, but pull it back up is really hard. That's one item. The other one is the ground. Sometimes as we go deeper, it gets harder to drill because the ground is just, the machine needs the power to cut through it, and it can't. There's another item that I think I have fixed that item, and I think it can be done. The drillers have done it before. They know how to do it. I think we got that expertise done. We had to justify the machine several times to make sure it goes down deep, because there have been, in the past, mistakes have been done. We all eliminated all of those mistakes. We are prepared. 2,000 meters, hopefully we get there. Going to this model, we are not going to do the drill hole 36, or we may. Drill hole 35 is for sure. Our next drill hole at this time is proposed to be here, and that's our gold system. On the top of this, we have gold with 9 grams per ton. The IP generally doesn't show it because gold behaves differently. Gold behaves less in the sulfides. Up the top of it, we have the sulfides. We have tested this on the ground that we have the sulfides right here, and this sulfide has been with 8-9 grams per ton in boulders. We've seen that, but at the bottom you see the IP doesn't show match, but the mag does show it. Geology shows it. At the surface, we've seen the sulfides happening, and that could be the gold rim for our deposit. Normally, these gold rims can be really, really rich. On one side, we have the Hoy, which historically and generally with our own geologist samples, we've seen 8-9 grams, and we've seen this. Technically, it makes good remark on that we should have gold in here and in here. Here, we are sure that we have it at least at the surface. This is the area that I'd like to close off for this season. And this is a big volume. If the whole thing, it has to be tested. There's nothing there. We can't say that. We cannot say this is the volume we have. But this is it's a big, big volume. This is about 4 billion tons volume. Has it been a volume for the deposit, the whole thing? And that's what we want to close off hopefully this year, and we want to focus on that. There's another thing I was going to mention in here. I'm going to turn off this one and show you the model this way. So this is a shell I made around that. I really like it. Look at this system that we are focusing right here. This is the lag zone south, and this is the north. This is the south. We're focusing on that. You see outside this shell, I hope it's visible, the mineralization is really rich. Still is going really good on drill hole 34. And in comparison to that, I'm putting this hole into it. If I bring down the shell like that, it shows to you we're aiming at the center of this zone. So far, we've had success with that. Technically and on the model and in the previous drilling, we've shown that this one works. And I'm turning that from the underneath the surface, you can see it. And this is what we're working on.
No, I think this is great for people. It really paints the picture almost quite literally, which is fantastic. So, thanks for doing this. This was great when you showed me. I think a lot of people now are going to really love it. And I'm glad that you're doing this in a video.
Neat. Thank you. Yes, I think people deserve to see it, and there's no other way you can show it really on the screen except this way and explain it to say what it is. This is what we're working on.